Alright, good morning everybody. Sorry I can't be there today. I just want to talk to you guys about transforming polynomial functions. What we're going to be doing and what you're expected to do on this last lesson for the unit is be able to take an equation of a transformation and be able to transform it and write a new equation for it. Let's do a little bit of review before we get into the topic here. Recall that when we were dealing with quadratic functions a couple of units ago, we would take this function here, f of x equals x squared, which would create that parabola shape right there. And then eventually what we did with this is we started modifying that and modifying how the graph looks. Now what you can notice here is that the parabola has its vertex right here at the center, the origin of the graph, and right there at 0, 0. And so then what we end up doing with this function here is we end up modifying the equation and end up creating new functions. For example, if we were to change this function here and now all of a sudden we look at a function that looks like this. What we've done here is a vertical translation, and that vertical translation shifted this function 3 units up from where the old vertex used to be. Now notice the vertex is right here at 0, 3. Suppose we look at another kind of function. What if it looked like this? Having the function say now f of x equals x squared minus 2, now that vertex has shifted. Instead of at 0, 0, now it's down to 0, negative 2. So when we have these numbers that are not in parentheses, remember we talked about this before, when the number's not in parentheses, that creates your vertical translation. Now when we started adding and subtracting values that were inside parentheses, in other words before we started squaring the values, what that created was a horizontal translation. And remember what that created here was that opposite game. Remember we said that with parabola graphing there was an opposite and same game going on. Okay, so whatever this sign was, that means we were going to go to the opposite direction. So if it said minus 2, we were going to go to the right 2 and have that vertex go right here at 2, 0. If we change it to a plus sign here, and now it says x plus 3 squared, and we're going to move it to the left. We move it to the left 3 units here, as you can see. And then what we started doing with these is started combining them together and doing both vertical translations and horizontal translations at once. Take a look at this one. In this example here, we have x minus 1, which means that we have to move this to the right 1 from 0, 0. And here with that plus 2, that means we had to move up. One thing that you have to remember, and I asked you this question many times in the past, was could you tell me where the vertex was at? And this is right when you were playing that opposite and same game here. So you guys were able to tell me that the vertex here would be at 1 and then 2. And so then you'd place it right there, and then you'd say over 1, up 1, and over 2 and up 4 to place those points right there. So notice that our horizontal translation takes place in the parentheses and the vertical translation takes place outside the parentheses. So let's flash ahead to the work that we're doing here today. So in the work that you're doing here today, let's take a quick look at the text box that we see over here with all these transformations now in table form. So right here you have everything that I was trying to spell out to you through that example there. You have your vertical translations, opposite, same game here, notice the plus sign there. Horizontal translation, opposite game right there. One other thing that we're going to look at here today is going to be that vertical stretch and reflection also. So let's just take a look at the first example and what we're going to be trying to do here with these problems. Alright, here's the deal. They're going to start you off with a function, and they want you to do the 2 following transformations. They want you to do 2 and 1. Notice this one here, they want you to stretch it vertically by a factor of 2. And then they also want you to shift it 3 to the left. So here's where you start. First step, let's just start and just get our function written down. So what you're going to want to do first is exactly what we see here. We want to be able to do just right in order here. So if we're to do these right in order, the first thing that we need to do is do a vertical stretch by a factor of 2. And so here's how this step goes. For your first step, whether it's a vertical stretch or if it's a reflection, which we'll see earlier, always apply those things by doing the distributive property. Watch how this works. When you're doing a vertical stretch, notice that all that's really happening to the function is that we're multiplying it by that factor. We're going to take whatever the function is given to us, and we're going to multiply everything by that number. So that's what we're going to do over here on that problem. So we're going to take the 3x cubed plus 6 and we're going to multiply it by 2. Why 2? Because they want us to do a vertical stretch by a factor of 2. So we're just going to apply the distributive property here, and then that'll give us our answer. Okay, so now we're in business here. We got our first function after we did a vertical stretch by a factor of 2, but we're not finished yet. Now what they want us to do is do a shift of 3 units to the left. So what I want your order of operation here for your next move here is to look for a vertical translation. Now, if you recall from the last problem, they didn't give us a vertical translation. Remember, left is a horizontal move. So since they're not asking us to do a vertical translation, which would be the same game, let's move on to step 3. And step 3 is just like we noticed right up here, which was a horizontal translation. So let's take a look at see how that gets done. So to properly apply the horizontal translation, what we're going to do is we're going to switch out the x that we see from the newly formed function that we had with the vertical stretch, which was a 6x cubed plus 12. Right? Remember, that's just from what we had before. And now we're going to swap it out with the x minus a parenthesis quantity. And to do that, we're going to play the opposite game. So what we're going to do is we're going to take this x that you can see right here, and only that x, not the 3 and not the 6. And we're going to swap it out with the quantity x. Now what are we going to do here? It says we want to shift it 3 units to the left. So what's the opposite game telling us that we need to write here for our parenthesis term? Yeah, the opposite game is going to let us use x plus 3 here. So now what we're going to do with that x plus 3 is we're going to take that x plus 3 quantity and we're going to swap it out with that x that you see right there. So we're going to move this guy right in there. So let's take a look at what we get out of that, which is going to be our final answer. And there you have it. And that's going to be the final answer that you're doing here. So let's try this again with another example. Alright, for this example, now we're going to take the exact same function that we started with, which I believe was what, like the 6x cubed, I'm sorry, it was a 3x cubed plus 6. And now we're going to reflect it across the x-axis and shift it 3 units up. Step 1 is going to be exactly the same as the first, which is applying the distributive property. Now why is it a negative 1 this time? Going in there and now creating our new function here. Well, the reason why it's a negative 1 is when you reflect it across the x-axis, take a look right up here in that list here. The one that's most important here is that reflection right down there. When we do a reflection here with this work, notice that the only one that we're actually doing here is reflecting it across the x-axis. So when we reflect across the x-axis, notice the only thing that we're doing here is taking the opposite of what the function is. So the opposite is the same as multiplying by negative 1. This is us taking the opposite of 3x cubed and taking the opposite of plus 6. There it is. So let's move on to step 2. Now does step 2 apply here this time? We want to do a shift of 3 units up. That's a vertical change, isn't it? So we can apply that step 2. So we can apply that vertical translation. Certainly the vertical translation here was 3. So what we're going to do with that 3, that positive 3, it's the same game here, is we're going to add that 3 to the function. Now when we add the 3 to the function, the only thing that we're going to be able to do here with these is combine like terms, and the only like terms we have here is that minus 6 with that plus 3 to create that minus 3 you see right there. And everything else just stays the same.